is not just dirt. Soil quality has to do with the physical, biological, and chemical properties of soil. Today we're going to talk about some of the physical properties of soil, including soil organic matter and structure, water holding capacity and infiltration, as well as compaction.
A fertile and healthy soil is the basis for healthy plants, people, and planet. Soil organic matter is the very foundation for healthy and productive soil. But what is soil organic matter and what does it do for us? Organic matter is the living dead and very dead components of the soil. Topsoil generally only has 1 to 6% organic matter, but a 1% increase in organic matter can increase crop yields by 12%. Additions of organic matter increase biological activity and improve soil structure and aggregation, which in turn improve water infiltration and storage, decomposition, and nutrient release. Soils with high organic matter act like a sponge, holding more water and nutrients. Organic matter also feeds the soil bacteria, fungi, insects, and other beneficials, which improve soil structure and fight plant diseases. The texture of soil is inherent. It has a certain amount of sand, silt, and clay. We can't change that. But how those soil particles fit together, the structure of the soil, we can change. A good loam soil is going to be about 50% soil and 50% air and water spaces. To maintain plenty of pores full of air and water for plants, we want to have good crumb structure. Soil scientists call these crumbs aggregates. The small aggregates are bound together by chemical bonds from organic matter and clay. Bacteria and root hairs produce sticky substances that glue soil particles together. Fungi and root hairs wrap soil particles into balls. One important type of aggregate is the water-stable aggregate. The number of water-stable aggregates in your soil shows its capacity to sustain its structure under the most extreme conditions, like a heavy rainstorm. Here you can see that very water-stable aggregates maintain their structure even after soaking. Others melt away. Do you have any soils on your farm that after a heavy rainstorm dry and form a crust? What happens when another heavy rainstorm comes? The water runs off the soil crust, not infiltrating into the ground where we need it, and taking precious topsoil off of our field. Cover crops, compost, and perennial cover will feed the soil organisms that bind together soil aggregates and help maintain soil structure. Healthy roots need air and water. When it rains, we want the rain to infiltrate into the soil, capturing it in the root zone where plants can get it. But we also want the soil to drain so the roots are not submerged in water without enough oxygen. The infiltration rate is an important soil property. It determines how much rainfall will infiltrate into the soil and how much will run off the soil surface. Here we can measure how quickly 1 inch of rain would infiltrate into soil from different parts of the orchard. We want to minimize runoff because it not only takes water, but nutrients and topsoil off of our field and into streams and rivers. When rainfall runs off, it's lost from the soil profile where it could be stored for plant use. Infiltration is mostly determined by the size of pores between aggregates, soil texture, and holes left by roots, insects, and earthworm burrows. When the soil surface becomes compacted by tractor tires or foot traffic, pores are compressed and infiltration decreases. Heavy tractors and traffic, especially when soils are wet, can compact the soil. Water will run off compacted soil crusts on the soil surface. Roots cannot penetrate compacted layers deep in the soil. We can measure soil compaction with a soil penetrometer. When we hit a layer that takes more than 300 pounds per square inch of pressure to penetrate, we know that roots cannot penetrate either. This is the depth we want to run the ripper, or we can plant biodrilling cover crops to break up that hardpan.